Welcome to evaluating limits graphically. We talked about this a little bit last time, and we're just going to do some more practice with it this time. So try the do now, and when you're done, resume the video to see if you got the right answers. Now, hopefully we remember that in order to find the limit as x approaches 1 on a graph, you should really find the left-hand side limit and the right-hand side limit. Remember that the minus represents left because negative values are on the left side of the xy axis, and we have that the plus represents to the right because positive values are found on the right side of the graph. So as we're coming from the left to 1, that means we're coming here and we're approaching x equals 1 from the left-hand side. We get a value of 2. Now we're going to come from the right-hand side. And when we come from the right-hand side, we get a value as we approach 1 of 3. That means overall, the limit of f of x as x approaches 1 does not exist. And we're going to write dne because the limit from the left is different than the limit from the right. Now, I just want to make a quick point that if we were talking about the limit of x equals 3, as you come from the left, we get 0. As you come from the right, you still get 0. So even though there is no actual point at x equals 3, the limit still exists. And the limit as x approaches 3 would be 0. Remember, a limit means the value that you get as you're approaching the point, not the actual value that you have at the point. And we're approaching 0 even though we might not actually equal 0, so that's okay. So we're going to try several practice examples. Now, they're asking us for the limit as x approaches -1. In order to find that, you need to find the limit as x approaches -1 from the negatives of p of x. We need the limit as x approaches -1 from the positives of p of x as well. So as we're coming from the left to -1, I have that we get 1. As we're heading from the positive x values, as we approach, I'm up here now because I'm on the right side of the graph, working my way over, and we get 2. Because these two values don't match, we're going to say that the overall limit does not exist. So keep in mind that anytime you have a jump discontinuity like we have here, that the limit will not exist at that discontinuity. Going on to as we approach x equals 1. So I'm going to find the limit as x approaches 1 from the negatives and the limit as x approaches 1 from the positives. As I'm coming from the left-hand side of 1, I get a value of 2. As you're coming from the right-hand side to x equals 1, you still get that value of 2. So we can say that the overall limit as x approaches 1 is equal to 2. Be careful, that's different than what p of x is equal to, because p of x is equal to, I'm sorry, not p of x, we're going to say p of 1. P of 1 is equal to 3. So keep in mind that the limit as x approaches 1 does not have to be the actual value of the function at x equals 1. So when it comes to point discontinuities, the actual point at the value we're looking at doesn't really matter. We're looking at what value does the function seem to be approaching, not what it actually is. Now, another example is when you're approaching x equals 2. So the limit as x approaches 2 of p of x, we're coming from the negatives, and we're also going to want to come from the positives, the right-hand side. And 2 is right here. So as I come from the left-hand side of the graph, and I don't really care what's going on all the way on the left side of the graph, I just care what's going on close to the point that I'm looking at. So I'm only going to look here. And you could see that the function gets to 3. Now, as you're coming from the right-hand side of the graph, we have an arrow, meaning that the function doesn't actually really approach a specific number. It's heading down towards negative infinity. Now, I know a lot of people are saying, aren't you actually heading up towards positive infinity? But that's not the case here, because what we're doing is we're specifically approaching from the right-hand side. So as we go from the right close to x equals 2, and we're heading to the left, the graph is decreasing in the direction that we're looking at. Anyway, since 3 is not the same as negative infinity, you could say that the limit does not exist. Because again, you have a discontinuity going on. So really, limits only exist when you're talking about a discontinuity that actually meets up in some similar fashion. Also keep in mind that if there is no discontinuity at all, then your limits are pretty straightforward and simple. For example, if you were looking at the limit as we approach 0, 0 is super nice because this is a continuous stretch of our function, which means as you come from the left, you hit 2. As you come from the right, you hit 2. Even at 0, you're at 2. So if the function is continuous at that point, your limit is whatever you actually happen to hit. Keep in mind that in order to find limits graphically, you need to find them from the left-hand side, the negatives, and from the right-hand side, the positives, and make sure those match in order to actually have a limit existing out there. And that's all for this video.